from section 1. Are there any questions or issues with that? Okay. Please get out your notes. We're starting section 2 today. So we are not going to get all the way through this section today. We're just kind of touching on a few things. The first thing on here are some rules that you're going to have to write down. In section 1, remember we talked about asymptotes a little bit. We figured out from graphing how to find horizontal and vertical asymptotes. We want to talk about in this section how to tell that from the original equation itself. So first thing I need you to do is write down this definition, okay? Now the first part, talking about the rational function. Remember, a rational function is just the division of two polynomials. So this looks really ugly, but it's just saying you have a polynomial divided by a polynomial. Vertical asymptotes are always just x equals a number that is a 0 of the denominator. So whatever makes the bottom 0 is a vertical asymptote. For the horizontal asymptotes, we have rules based on the degree. So I'm just going to give you a little bit of time to write this, and then we will talk about it. Okay, so to find vertical asymptotes, you just set the bottom equal to 0, which we talked about Tuesday when we talked about the domains. Basically, the values that x can't equal are where you get those vertical asymptotes. The horizontal asymptotes are based on the degree. So if n is less than m, that means if the degree on top is smaller than the degree on the bottom, then it's automatically y equals 0. If it is the same degree on the top and bottom, then you divide the leading coefficients. And if the degree of the top polynomial is larger, then we do not have a horizontal asymptote. So the way to get a horizontal asymptote is if the degree of the top is smaller or the same as the bottom. And we will divide the leading coefficients if they are the same. If it's smaller, it's just an automatic 0. The oblique asymptote, we will focus on, start talking about today and continue working with next week. It's not as clear-cut of a rule. It happens only in the scenario where the degree of the top is 1 larger than the bottom. So like an x cubed over an x squared, an x to the 4th over an x cubed. That's when we get an oblique. And we have to find it by doing long division. One more thing that I want to mention along with these asymptotes, something that we've done many times, but I will be asking questions about intercepts as well. How do you find an x-intercept? Same as, yeah, cover-up method. With the line, you just covered up the opposite variable. So essentially, to find an x-intercept, you let your y, or if it's written in function notation, that's the f of x, equals 0. To find a y-intercept, what do you do? Cover up the x, let your x equal 0. So if I ask you questions about those, you're just plugging in 0 for the opposite variable. practice, we'll start first with let's jump right in with finding asymptotes. Okay, I want all of the asymptotes. When we're finding the asymptotes, you will not have both a horizontal and an oblique. You can have one or the other, but we'll always have to check vertical and then either the horizontal or oblique. To find a vertical asymptote, what do I need to look at? The denominator. It's what makes the denominator 0. So if I set 4x squared minus 1 equal to 0, to get rid of a square, we square root. When we do that, we do plus and minus. We get x equals plus and minus. Square root of 1 is 1, square root of 4 is 2. So I have two vertical asymptotes, x equals 1/2 and x equals negative 1/2. I am going to require you to write these as an equation. If you just say vertical asymptote plus and minus 1/2, I will take off because it is a full line, so you have to give me the equation of the line. Vertical is x equals, everything else is y equals. Now we have to decide if it's horizontal or oblique. So we look at the degree. What is the degree of the numerator? The degree of the denominator. Okay, if it's the same degree, it is a horizontal asymptote. And we find it by dividing these leading coefficients. So we just have to do 8 divided by 4, and we get y equals 2 for the horizontal. And if we have a horizontal, can I have an oblique? No. You don't have to write this. I'm just going to say oblique asymptote, none. But unless I specifically asked if it had one, you wouldn't have to state that. Okay. Why don't you guys try B for me? Find your asymptotes. You set the bottom equal to 0. You get a -4, x equals -4 for the vertical. Horizontal or oblique, what's the degree of the top? Bottom. So if it's the same degree, all you do is divide the leading coefficients. This is like a 3x over 1x. So you have to do 3 divided by 1. So y equals 3 for the horizontal. That means there is no oblique. So far, so good? This is just what we're doing today. We're just going to keep practicing finding the asymptotes. So, vertical asymptote. You set the denominator equal to 0. When we do a square root, what are we getting? Okay, in terms of our graph, can we graph i's? So what would I say for my vertical? None. There won't actually be one on our graph. Alright, decide horizontal or oblique. So degree of the top, bottom. Alright, if the top is smaller, it's a horizontal. And the rule is just y equals, look back at your rules. the first one. If the degree on top is smaller, it's an automatic y equals 0. It's kind of like the other rule we are dividing the leading coefficients. If there's no x squared on top, that's like a 0x squared. So if you did 0 divided by 1, you get 0. So it's kind of the same thing. If the degree on top is smaller, it's always just going to turn out to be a y equals 0. And so of course that means there is no oblique. Okay, let's look at D. So vertical, we set the bottom equal to 0. Alright, how am I going to solve that? Yes. Greatest common factor, we can plot an x. And then we can do box method. So x squared breaks into x. What multiplies to -2 and adds to -1? -2, positive 1. Okay, so if I set each of these things equal to 0, if it's just a plain x, you get x equals 0. If x minus 2 equals 0, we get 2. And if x plus 1 equals 0, we get -1. So this graph has 3 vertical asymptotes. Is that one okay? Now let's look at our degree. Degree at the top is 4. Bottom, we have a horizontal if the degree on top is smaller or equal to the one on the bottom. So that means right now I know there is no horizontal asymptote. It is oblique. Oblique happens when the degree on top is 1 bigger than the bottom. So, an oblique asymptote is just any other line. Think y equals mx plus b. We have to find this by long division. Unfortunately, we can't just do synthetic because the bottom isn't linear. So to do a long division, the denominator goes on the outside. And the numerator goes underneath. We might put in like a 0x cubed. I'm going to run out of space. A 0x and a 0. I'm going to rewrite this. I don't have enough space there. Now, the good news is I don't have to do the full long division. We just need a line. Y equals mx plus b. So basically, I have to get my m and my b, and then I'm done. So if you remember, when we did long division, you start out with your first terms, and you divide them. So like 3x to the 4th divided by x cubed. What does that give you? That's 3x. Okay. Then you multiply. You do 3x times this. So that gives me a 3x to the 4th minus 3x cubed minus 6x squared. What do we do now? We subtract it off. So easiest way to do that is just run a negative through. and then you can add. So these drop. 0x cubed and 3x cubed is 3x cubed. Negative x squared and 6x squared is 5x squared. Okay, we are actually very close to being done. We have to divide again. So we're doing 3x cubed divided by x cubed. And that would give us a 3. That is all I need. I have my mx plus b. So my oblique asymptote is y equals 3x plus 3. You will never have to finish that long division. You just have to get your x and your constant term. So oblique asymptotes are definitely the most difficult to find. Have to kind of go back a little ways and remember that long division from before. What questions do you guys have for me? Okay. Do you just want to do another one? Okay. So let's say this was my rational. So the degree on the top is 2, degree on the bottom is 1. So if the top's 1 bigger, that's oblique. We set up the long division. The numerator goes underneath. The denominator goes outside. So then we start with our first terms and we divide them. So 5x squared divided by x would give us just a 5x. So that goes on the top. And then what do? Multiply. So I have to take the 5x times that x minus 6. So we get 5x squared minus 30x. What do we do from here? Subtract. So I have to change all of those signs. So then the x squares cancel, 3x and 30x gives us 33x. And you can bring down the plus 4 if you want. Then what do? Divide. We're taking the 33x divided by x. And we get, that is all you need. So your oblique is y equals 5x plus 33. You don't have to keep going. 5x times negative 6 when you distribute. I'm not used to my touch screen working. It's kind of nice. It works. Everything works again. Do we need to do another sample division? Let me give you guys one to try. Okay, you guys find the oblique asymptote for this one. So just the oblique. Divide. 4x cubed divided by x squared is 4x. Then you multiply 4x times that thing on the outside. So we get 4x cubed do now, change the signs. Because we want to subtract it off, so it's easiest just to run a negative through and then add like terms. So those drop. A positive 2 and a negative 4 be a negative 2x squared. You can bring down this other stuff. We're really not going to need it, because the final step is just to repeat. Divide. Negative 2x squared divided by x squared is negative 2. So your oblique is y equals 4x minus 2. You don't have to finish it. Okay. Let's do 2 more examples of finding all the intercepts, or finding all of the asymptotes, and then I'm probably done for today. Okay. Vertical asymptote. Set the denominator equal to 0. What do I need to do there? Box. Multiply to 6, add to negative 5. So my vertical asymptotes are x equals positive 3 and positive 2. Alright, let's decide horizontal or oblique. What's the degree at the top?
3.
Bottom? Okay. Degree of the top is 1 bigger, so that means we don't have a horizontal. We have an oblique. So we get to practice our division again. Inside, we put the x cubed minus 8. If it helps you, you can put 0x squared and 0x in there. Not required, just kind of helps keep track of your terms. So first step, you divide. X cubed divided by x squared. That's an x. Multiply. X times x squared is x cubed. X times negative 5x is negative 5x squared. X times 6 is a 6x. Change all of the signs, because we want to subtract that off. Divide again. 5x squared divided by x squared. 5. So our oblique is y equals x plus 5. Is that one okay? I didn't ask for it, but what if I had said, what is the x-intercept of this graph? What would you do?
Plug in 0 for your oblique.
For this h of x, that's like your y. So you plug in a 0 for that.
Yeah.
If you wanted to get rid of the fraction, you would multiply over the bottom, but 0 times anything is still 0. Add over your 8. Cube root of 8 is 2. So your x-intercept is 2. Or if you wrote it as a point, it's 2, 0.
How'd you get rid? You just got rid of the bottom or something?
Yeah, if you multiply it over, then 0 times anything, it's still 0. So I just multiplied over that bottom. Like, think if I had said 0 equals x over 5. You would take it times 5 on both sides.
Oh.
And 0 times
Yeah,
5 is still 0.
That makes sense.
Y-intercept. What would you have to do to find it? If I made all my x's 0, you get -8/6 or -4/3 for the y-intercept. So we will talk more about intercepts next week when we start drawing the graphs, but I figured it wouldn't hurt to look at them on one example. Last one for the day, finding the asymptotes on F here. Vertical asymptote. Set the bottom equal to 0. With asymptotes, we don't have to worry about multiplicities or anything like that. To get rid of a fifth power, you just do a fifth root, and we get x equals 0. What's the degree of the top?
8.
Bottom?
5.
Okay. Horizontal happens if the top is smaller or the same, so it's not horizontal. Oblique happens if the top is just one bigger, so it's not oblique. There is no horizontal or oblique on this one. Any questions for me?
Hopefully you get all those.
Okay, so the assignment, we already talked about that, is a Math Excel. It's like 10 questions again. Most of them, it just gives you a function and asks you which of these things is true. So start by checking your asymptotes.